Have you ever felt like you're just trying to memorize a bunch of terms when it comes to object-oriented programming? Well, if so, you're in exactly the right place. Today, we're going to finally build a mental model that makes all those concepts, encapsulation, polymorphism, finally click together. Let's dive in. Does this feel familiar? You've learned about classes, you get what inheritance is. Encapsulation kind of makes sense, but then you go to start a real project, and it just feels like you're guessing, right? It's like you know all the ingredients, but you have no idea what the recipe is. And if that sounds like you, trust me, you are not alone. This is probably the #1 question people have. It's that gap between knowing the definitions and actually thinking like an object-oriented programmer. And today, we are going to close that gap for good. So, here's our game plan. We'll start by talking about the problem itself. Then, we're going to build a really practical example from scratch. We'll see how each OOP pillar solves a specific problem for us, understand why this approach is so powerful, and then we'll finish up with a simple toolkit you can use from now on. Okay, so here's the real issue. Just memorizing that encapsulation protects data or inheritance reuses code, well, that's not really going to get you very far. The real power, the absolute magic, happens when all these concepts start working together to create code that's clean, flexible, and really solid. To see that teamwork in action, we need a mission. So we're going to build a super simple school system. Nothing complicated, no databases, no fancy UI, just a clear, real-world problem that's going to force us to use every single pillar of OOP the right way. And here are the rules of the game for our little system. We know there are people. Some of them are students, some are teachers. Every single person in our system has to be able to introduce themselves. We also need to make sure their private details, like their name and age, are protected. And finally, those rules have to be enforced. These requirements are going to be our guide. All right, it's construction time. We're going to build our school system piece by piece. And with every piece, we'll see exactly which OOP pillar we're using, and more importantly, why we're using it. So, let's start with the foundation. We kick things off with abstraction. I want you to think of this as the master blueprint for our school. Before we even think about what a student or a teacher is, we have to lay down the law about what it means to be a person in our system. We're setting a contract that every other type of person will have to follow, no exceptions. Now take a look at the code. See that little @abstract method thing? That's our enforcer. It's a non-negotiable rule that says, hey, any class that wants to be a type of person must have an introduce method. We're not saying what it does yet, just that it absolutely has to exist. That's abstraction in a nutshell. Next up, encapsulation. This is our security guard. We definitely don't want some other part of our program to just waltz in and accidentally change a student's name or age. Encapsulation is what bundles that private data together with the code that can change it, and it keeps everything else out. And here's exactly how we do it. See those double underscores right before name and age? In Python, that's not just a suggestion, it's the language actively protecting those attributes, making them private so they can't be changed directly from the outside. This is how we keep our data safe and sound. Now for inheritance. This is all about efficiency, being lazy in a smart way. We've already got that person blueprint, so instead of rewriting all the common logic for both students and teachers, we can just have them inherit it. It's the ultimate don't repeat yourself principle. And the code for it is just beautiful, isn't it? It's so simple. By just putting extends right after the class name, we're saying a student is a person and a teacher is a person. And just like that, they automatically get all the features of the person class, including that strict rule about having an introduce method. And that brings us to the coolest one, in my opinion, polymorphism. It literally means many forms. This is where our whole design becomes incredibly flexible. We have one single method name, introduce.ch, but it's going to do completely different things depending on whether we call it on a student or on a teacher. Okay, this right here is the aha moment. Just look at how clean and simple this code is. Imagine we have a list with both student and teacher objects all mixed together. We just loop through it and call p.introduce on every single one. Notice what we're not doing. There are no if statements checking if P is a student or a teacher. We don't have to. And boom, here's the payoff. The exact same method call, p.introducing, gives us completely different, perfectly appropriate results. The student says they're a student, and the teacher says they're a teacher. One name, many forms. That is polymorphism. And this right here is the secret sauce of professional level design. The part of our code that's managing this list of people, it doesn't know anything about roll numbers or subjects. It doesn't care. All it knows is that every single object in that list is guaranteed, thanks to abstraction, to have an introduce method that it can safely call. So you might be thinking, okay, that's neat, but why go through all this trouble? Why is this design so much better? Well, this is what separates fragile, hard-to-maintain code from the kind of rock-solid systems that are used to build professional applications. Think about it. Our OOP approach gives us a clean structure, our data is safe because of encapsulation, and our code's behavior is super flexible thanks to polymorphism. The alternative, the beginner approach, usually ends up as a tangled mess of logic with data that's exposed to anyone and tons of duplicated code everywhere. We've avoided all of that. Okay, let's bring it all home. We're going to distill everything we just did into a simple, powerful mental toolkit that you can carry with you into every project you work on from now on. These are the core ideas that'll guide your decisions. Here it is, your brand new OOP mental model. When you think of abstraction, I want you to just think of the word rules. For encapsulation, think safety. Inheritance is all about reuse. And polymorphism is flexibility. Rules, safety, reuse, flexibility. That's it. That's the heart of it all. And let's do a final lightning round recap just to lock it in. A class is the blueprint, an object is the real thing you build from it, encapsulation protects your data, inheritance lets you reuse your code, polymorphism means the same name can do different work, and abstraction hides all the messy complexity by setting the rules up front. So what does all this mean for you right now? Well, after walking through this, you are now equipped to look at real-world code and actually understand the why behind its design. You can start building your own programs on this solid foundation, you can read professional frameworks with way more confidence, and, most importantly, you can stop fearing OOP. We've gone from just knowing a bunch of separate definitions to having a unified, practical understanding. You don't just know the ingredients anymore, you actually have the recipe for building clean, powerful, professional code. The blueprint is yours now. So the only real question left is, what are you going to build first?